Okay, welcome to the first class meeting of EECE341, Introduction to Communication Systems. As I just told you, we have two home pages. One is on PLMS system, and the other is on my lab homepage. So if you click the first link, you will be directed to my lab homepage. And my lab is CISL, Communication and Information Systems Laboratory, now changes to Communication and Intelligence Systems Laboratory, kind of conforming to the trend these days. And then if you click the teaching link, then you will be directed to my every courses. For example, let's go to that link. And you will see every courses I have been teaching. And most of the courses, you can find a recorded video. So if you have forgotten, for example, the materials covered in signals and systems, which is a prerequisite for this course, then you may go to signals and systems and schedule and download. Every course page has the same format, so you can easily find. So you go to, for example, Signals and Systems, schedule and download, and you will find every handout and annotated handout and even the video lectures. So this is a kind of a vault for your electrical engineering courses. And here, especially, we have the link for this course, EECE341, Introduction to Communication Systems. And I've been updating this first page. And again, on top here, you have the schedule and download link. And you can find today's handout. And as I just told you in Korean, if this handout has chapter 01, then when you click this one, you are asked to punch in the password, and the password is ONE simply. So in this way, you can access most of the course materials, password protected, whether the material is of this course or other courses. For example, if you go to the Signals and Systems, schedule and download, and you find some password protected material, again, you type in, for example, FOUR for chapter 4 material, something like that. Got it? So I hope nobody will ask what is the password of such and such material. However, according to my experience, some of you will continually ask me, Professor, what is the password? And I know that, and I will forgive you, okay? Okay, then here goes the syllabus. By the way, what is the syllabus of a course? Syllabus is a kind of contract between you and I. The problem is that I make the contract, okay? So if you don't like it, you can just drop the course. However, until the second week, which I believe the add drop period, we can discuss. I'm kind of democratic people, not a dictator. So if you, majority of you ask me to do such and such modifications on this syllabus, then I will think about that. If it sounds reasonable, then I will modify the syllabus. However, after the first 2 weeks passes, then this contract cannot be modified unless everybody, including me and every one of you, agree to change the syllabus. Got it? So it's a contract between you and I. So this is a draft of contract. If you don't like it, there are two choices. Come to me and ask a modification, or you choose another course. Got it? So this course is a mandatory course. It's a kind of a strange thing, but the mandatory selective course for electrical engineering. And this is also an elective course for the next generation communications and network minor. Minor means 부전공, major means 주전공. And if you major, double major, that is 복수전공 in Korean, okay? So this is an elective course, elective mandatory, strange thing, course for electrical engineering, and it's a elective mandatory course for NGCN minor. Class meetings will be on every Monday, Wednesday, 9:30 to 10:45 at this classroom, LG 102. And for exceptions, you can again find from schedule and download. So this schedule and download is very important. Of course, still the PLMS homepage is important. I will post a lot of material there, especially related to homework, especially homework is true, false, or OX, or multiple choice problems. Because in that case, I can alleviate a lot of burden on my TA, because PLMS system will automatically grade. So sometimes homework will appear on this lab homepage. Sometimes it will appear on PLMS. I will let you know every time I will upload it. Got it? So you will receive a lot of short messages from me. So if the short message starts like 정보통신공학개론, then I or my TA have sent to you. Got it? So usually the message will be short. If it is too long to be fit into the window of that short message window of PLMS, probably read your email, something like that. And then you can find my long message from the email. So you need to regularly check your post-tech email. Okay, so let me continue covering this syllabus. So objective of this course is to let you have an overview of communication systems. So this is a kind of introductory communications course. It includes not only analog communications, but also digital communications. However, we have a separate digital communications course for seniors. So you may take it next semester, spring semester of 25. My name is Junho Cho, and I have my office on the 4th floor. You can send me an email, or you may approach me before and after this class meeting for 15 minutes. We have a TA and tutor. TA's name is Moon Jin-hyuk, and you will rarely meet him unless you have a complaint about your graded homework or quiz or exam. We have a tutor, undergraduate tutor, Lee Soo-yoon, and he will contact you soon about which kind of format for you to have for this tutoring. Already I told you what is the homepage, and PLMS is, I said, also important. And lecture handouts, videos, annotated handouts can be found from schedule and download of my lab course homepage. Also, I have a YouTube channel. So if you go to this one, okay, yeah. Currently, just some third-party made courses, but you can go to, for example, yeah, my channel, and here, let me see, you have a lot of playlists like graduate level information theory, graduate level statistical signal processing, undergraduate 전자수학 A, 확률 및 random process, probability and random processes, and some other courses, especially signal gen systems. And similarly, this semester, we are going to fill up this playlist with my around 28 lectures, class meetings. Okay, about the textbook. Textbook is the book by Jimmer and Tranter. I have the favor for this textbook. When I was an undergraduate student, my introductory course had this book. It's probably second edition. Now we have fourth edition, published 10 years ago. And you may say that, okay, this is the professor who used the textbook 10 years old. But what about your math courses? Is it about 300 years ago, calculus? Okay, so don't complain. I will kind of provide you most updated information that does not appear on this textbook. Okay, so this book is very, very well written. I can dare say that this is one of the best undergraduate introductory communications textbook. There are two types of textbooks. One is a group of textbooks that can be used for self-study. And the other group of textbooks are textbooks for kind of lecture note type. So the second type of textbooks are usually very hard to read unless you take a course together with that textbook. However, this textbook is very well written. So even if you don't take this course or you decide to drop this course, still keep the textbook. That textbook is one of the best. And when you read it, you can really understand the material. There are some type of badly written textbooks. You read it, you read some part, cannot understand the material. You read it again, you cannot understand. You read it around 7 times, and then you start to memorize all the words there, and you deceive yourself to understand that material. There are that kind of textbooks badly written. However, this book is very, very good. Got it? By the way, we have references, especially the first one is the undergraduate signals and systems textbook. This is prerequisite, so I recommend you review the undergraduate signals and systems material within 2 weeks. So some of you have been already seen from the schedule and download. We are going to have our first quiz after the Chuseok break. And this quiz will cover the signals and systems part. Not every signals and systems part, but especially the Fourier series and Fourier transform, continuous time, Fourier transform, and series part of the signals and systems. So be prepared. Got it? The first quiz will be held on Monday during the class meeting. You have around 30 minutes, so not enough time to think about it. Try to understand and memorize all the important results like formula for Fourier transform. Otherwise, I recommend you not to take this course. This course heavily relies on signals and systems. Okay, there are other textbooks like Peyton-Peebles' Probability. That book was adopted in the 전자수학 8, the EECE341, I believe. You can, of course, use other textbook for probability. I'm not going to talk too much about probabilistic something in this course, even though our textbook assumes that. So about the probability part, you can just skip it, okay, for the prerequisite, because it's not a prerequisite, it's recommended for your better understanding. There are other undergraduate textbooks. Some of them are very poorly written, but very popular. Poorly written here means that it can be a good textbook for a course. However, it's not a good textbook for self-study. Got it? Anyway, they are very popular books. Here goes the course outline. First, we are going to cover a brief history of communications. And here we go, signals and linear systems analysis. So this part will cover the prerequisite. Of course, I will cover it very, very quickly. So you study yourself. And then we are going to talk about linear modulation techniques, angle modulation and multiplexing, baseband digital transmission. And here goes review of some probability and random variables. However, as I just told you, I'm not going to heavily use this material in this course. Of course, random signals and noise is very important. I'm not saying that I will never talk about random variable, but I will try to minimize. Digital data transmission in noise, optimal receivers, signal space concepts, and then finally, information theory and coding. Of course, this is my plan, and plans are usually modified. And some of you already know my style, so I talk a lot. So sometimes we will not have enough time to cover all the material. For example, it's now December 1st, and we are still doing this. Okay, it's highly likely. Then what I'm going to do is that I will skip, in that case, all the other part except this one. Because as you find from the title of this course, the title in Korean is 정보통신공학개론. Of course, the English title is Introduction to Communications. Probably most of you have expected what is the meaning of information, right? So I will never forget chapter 10, Information Theory and Coding. By the way, fortunately, this semester, we have a graduate level information theory course. So the course is EECE341, information theory. So if you believe you study very hard, especially in 전자수학 A, EECE341, is it 301? Yeah. Then you can take it without much difficulty. However, if you are not well prepared for the probability random processes part, and you may suffer taking this course. So if you are a very ambitious guy, try to take this course. By the way, I'm not teaching this, and Professor Yongjun Kim will teach this course, and he's a very good teacher, so you may enjoy a lot. By the way, these are companion courses all related with information and communication. So we have, okay, it's 302, okay, 전자수학 A is 302. And we have electromagnetic wave, data communication, and computer networks offered by Computer Science and Engineering Department. We have digital communication. Not all of them are offered this semester. Most of them are offered in the spring semester. We have Introduction to Communications and Network, of course, will be offered next semester. We have lab course. Unfortunately, the slot is full. We have digital signal processing, microwave engineering, and other courses. Okay, here goes the course requirements. Requirements means that if you, for example, do not appear in final exam date, whatever score you get from other requirements, you fail, okay? Got it? Requirements means that it is required. Even though it occupies 30%, if you don't submit any homework, you get F. Got it? So, by the way, we have very high percentage assigned for homework. I value the importance of homework in order to keep you study. So there will be 2 exams, midterm and final. And as I already announced, we have the first quiz on Monday, immediately after the Chuseok break. So it's on September 23rd, exactly 2 weeks from today. And other second quiz will be announced. By the way, the exams will be taken in this classroom on Mondays, got it? From 7 p.m. to 9 p.m. Okay, so you schedule them ahead, got it? Sometimes I and TA give you more time. And the legend says that Professor Cho gave around 10 hours to finish the exam. And you may not believe, but it's okay if the TA and all of you agree. Got it? So some students, I remember, at 7 p.m., I handed out the exam questionnaire book and read the problems and slept 4 hours and woke up at 11 p.m. And then the students started to solve the problem. I still remember that day. Okay. About the percentages, be careful, be careful. I usually use G scores, okay? So 30% really means 30% in terms of Z score, okay? So it's completely kind of reflects your relative position. For example, everybody got very, very low score. It's okay, okay? So your score, from your score, the average will be subtracted and the quantity will be divided by the standard deviation. So it's important for you to relatively work well on this course. So sometimes the mean value is very, very small, but some of you get very high score. I've seen a student who got around 2.0 sigma. And unfortunately, he didn't join postgraduate school, but went to Stanford. Okay. By the way. Anyway, about the attendance, this is very important. Some of you will be viewing this first class meeting without coming to the class. And you didn't come to the class today, okay? You use the system. I will use the post-tag electronic attendance system. So you click this link and check whether your presence at the specific class meeting is correctly reflected. And our school regulation says that minimum attendance of 3/4 of the class meetings is required. What does that mean? For example, if your absence goes over 1/4, then I cannot give you any other grade than F. Got it? It's school regulation. However, there are sometimes you have to be absent due to excusable reasons. That is termed as excused absence. In that case, you submit related relevant documents to me and my TA. Then I will log in to the post-tag electronic attendance system and correct your absence to presence. Got it? And some of you who has not come to this first and second, even third class meeting says that, okay, I didn't at that time enrolled in the course. It's okay. I don't take any score from your absence unless you are absent more than or equal to 1/4 of the course. So you can just skip 1/4 of the courses without getting any penalty. Okay. Of course, you can come to this class meeting and do anything. For example, you can do your circuits homework in this class meeting unless you disturb other students. Got it? You can even sleep during this class meeting unless you snores. Okay? Got it? So unless you make me very annoyed in this class meeting, you can do everything. Okay? So it's your freedom. I believe you are now adults, so you are responsible for your choice. Okay? But let me repeat. If you have more than or equal to 1/4 of the inexcused absence, then I have to give you F. Got it? Otherwise, you will not be penalized by any your absence. Okay, I will talk about extra credit voluntary final report, probably after the midterm exam. And you may have interest in this, but not today. Okay, so we have covered our syllabus. Any questions? Any questions about the syllabus? If you don't have any question, I will directly go to the first handout. Any question? Okay, let me continue. So the first handout is entitled Brief History of Communications. And there is an episode saying that when I became a graduate student, I attended Purdue University in the United States. So there was around, at that time, around 20 Korean students, new graduate students. The Purdue University is not that well known at that time to most of the people. So only around 20 Korean new graduate students came in the year 1995. What was you in 1995? Some of your material was inside some vegetable. Some of your materials composing yourself, probably in some grass or some cow, I don't know. Anyway, and we had a welcoming party. And one of the senior Korean graduate students says that, hey, Junho, there will be another party only for the new graduate students, new Korean graduate students. And he said that female students will also come. So I attended that. And there was a time for us to introduce our majors. And there was one beautiful female student said that, my name is blah, 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 and I major in communication. Major in communication. And we didn't see her in any class meetings. So we asked, which department are you with? And she said, what? 신문방송학과였어요. So communication may mean a lot, even in academia. Sometimes it is all related to 신문방송학과. Sometimes it's all related to electrical engineering and computer engineering. However, this plural S sometimes means a lot. Communication may mean a lot of things, but communications may mean a little bit smaller something. And in electrical engineering, if we talk about communications, it means communication technologies. Okay, so this means comm technologies. And unfortunately, when I talked about this importance of character S to our postdoc professor majored in communication, the professor told me, no, that is not true. They also use communications to mean something totally not related to electrical engineering. So I have to retract my claim that if we say communications, it means communication technologies. However, still, it is widely admitted. So you'd better use this character S if you want to emphasize you major in communication technologies. Anyway, these handouts for this course is written by Professor Kyung-Chul Yang, who is on sabbatical leave this semester. So I'm kind of a pinch hitter. And I modified his handouts in order to be more tasteful for me. Okay. So here goes the first slide. Welcome. Welcome to the exciting world of information and communication technology. You are living in one of the best era of human beings. Can you believe that? This is the best time. You don't believe, right? When I was at your age, there was no smartphone. There was no web browser. Can you believe that? There was no Google. There was no YouTube. There was no Netflix. Amazing. So, by the way, probably you don't know him. And he's not a celebrity, but a postdoc graduate. Okay? Of course, he was not a postdoc undergraduate, but after getting a bachelor's degree from some good university located in Seoul, he joined a postdoc graduate school, especially our department. And he majored in, I believe, RF circuits, probably amplifier, I don't know exactly, mixer, or I don't know. But anyway, he joined one of our labs and got master's degree and PhD degree, and then joined Samsung Electronics. And usually when a graduate student got a degree in higher degrees, usually they want to do research. For example, they want to become a researcher in Samsung. But he decided to go to the manufacturing line. Of course, it's not just soldering something, but so he went to Gumi, you know, right? At that time, there was the largest cell phone factory of Samsung, or probably world largest cell phone manufacturing factory located at Gumi at that time. And he contributed a lot to improve the production line. And his smartness and his capability was recognized. And then at a very young day, he was promoted. And now he's the head of Samsung MX, the cell phone mobile devices business. And I believe this is last year's photo, or this is photo. But anyway, cell phone and some smart watches, and this is a foldable phone. Yeah. You can become the CEO or one of the CEOs of Samsung, as he did. And some of you already know this is that Starlink satellites. So currently, our communications network evolves from terrestrial, here TN means terrestrial network, 지상 network, into non-terrestrial network, 비지상 network, including satellites, high altitude platforms, and other things, drones. And also, what is this one? This is submarine internet cables covering the entire globe, and some autonomous vehicles, remotely controlled. And all of this was unimaginable when I was at your age, okay? You may not believe. When I was at your age, in order to connect to some communication network, I had to use dial-up modem, which means that my modem connected with my PC was connected to my home telephone network. And at that time, the data transmission rate started from 2400 BPS, which means that in 1 second, you can send 2400 bits. Got it? And then suddenly, when I was about to graduate, it improved up to 9600 bits per second. Can you believe that? 9600 bits per second. Very slow, right? Your 5G or Wi-Fi has what? Some gigabits per second transmission rate. So let's see. Suppose you now have 2.4 gigabps, for example, which means that 2, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is it correct? Got it? So around 30 years, our human being achieved amazing thing. Can you believe that? In 1 second, you can transmit this many bits through your communication system, through wired internet, through wireless internet, some satellite communication. Of course, in this case, the transmission rate is much lower, but it's still some megabps. Got it? What motivated this improvement? Of course, human greed. You have to understand human greed in order to predict the future. Okay? At your age, I didn't know that. At your age, I was a very idealistic person. So I believe that our human history was a struggle to achieve freedom. Okay? So think about this 150,000 history of human beings. We started from prehistoric era. We used the stones to make our tools, bronze, iron, and sometimes plastic, wood, right? And what happened? Even at the Middle Age, most of the humans were under oppression. We didn't have any freedom. Most of us, not us, our ancestors, right? We couldn't plan our life. Suddenly, there were some revolutions in England, for example, you know, and in France, in Russia, and in other countries. And our ancestors, most of us are all liberated. However, still there have been a lot of oppressions, right? Some racial oppressions, some gender oppressions, some other bias-based oppressions. And still, we are not all completely free. However, most of us feel that we are mostly free. Now, given this freedom, what do we do? What do our human being do? We are all very greedy. We want to just become very wealthy, for example. Without doing anything, we want to enjoy everything. That is the nature of human being, liberated by oppression. And we want to spend our all day just watching our good partners from Netflix or some Gundam series without studying, right? We hope our lottery purchased yesterday become economic, will give us economic freedom. That is all related to our human greed. And interestingly, when I was in your age, when I decided to major in communications, I thought that communications, this communication technology, contributes for very important part of our life, human life, sending very important information throughout the world, very far away, space probe, something like that. And suddenly, this communication technology became very, very popularized due to the greed of my fellow communication engineers. They improve the transmission rate how many times? Million times? And what happens? Even we cannot store all the information we just received from the network, and we just play it and delete it from the memory of our cell phone. It's kind of has become an infrastructure conveying a lot of very important information. However, that well fits for the nature of human being. We are greedy and we do not want to work hard. We want to just enjoy our finite time of our life. Anyway, that will continuously motivate the growth of all the technologies, economy, and everything. So some of you will not come to this class meeting from this Thursday. However, please remember what I have just told you. Try to understand the nature of human beings. And your answer, your own answer may be a little bit different from my answer, but my answer is that we are very greedy. And that motivates all the evolution and all the improvement in our society. Anyway, so we are living in a wonderful era of human being. Now, most of you know this painting. And this is Peter Bruegel's 1563 painting. And it pictures so-called the Babel Tower in Bible. And here goes my question. By the way, I'm not a Christian and I'm not spreading Christianity through this course, okay? So don't say in some post that the professor looks like a Christian and wants to convert all of us through his course. I'm not that. Okay, anyway, the question, why did the tower collapse? According to the Bible. I'm not a Christian, but I know this story. Why? Okay, anyway, the God got angry because our human being tried to reach the sky, probably heaven. So he decided to prevent from us to reaching the heaven or sky. So what did he or she do? If I were he or her, probably I gave earthquake or a lot of bolts. But he or she, the God, decided to what? Decide to, yes, to use different languages. Then what happens? The workers building the tower could not communicate each other. And what happened? It collapsed. Okay. So you see the importance of communication. Without good communication, not only the Babel Tower, but also our wonderful era cannot be sustained. Then here goes the question, why do we communicate? And here goes the answer. To reduce or remove the imbalance in information. So it's kind of replacing questions with other questions. Why do we communicate? Due to the reason for us to communicate is due to the imbalance in communication. Then what is information, right? Probably many of you have thought about that. What is information? What's the definition of information? And actually, from that definition, a lot of different subjects, different majors spreads out. In electrical engineering, information is defined mathematically. And that theory is so-called information theory. And as I told you, you can take it this semester. Okay. There it is, information theory. And as I told you, information theory heavily relies on probability, random variables, vectors, and processes. What does that mean? We are mathematically model or mathematically define what is information. And then we talk about how we store the information, how we transmit information and how we process information. And some of the answers about these hows will be answered in this course. However, not all the materials can be covered in a single course. I had to study a lot of courses and read a lot of papers and think a lot to partially understand what is communication and what is information. So this single course cannot or may not be completely satisfy you. However, I will try my best. Okay, so let's defer our discussion about what is information. If you have questions and you really want to get an answer, why don't you think a lot about definition of information from today and until I cover chapter 10, okay? Here goes the very important part. I gave you a hint. In electrical engineering, we mathematically define what is information. What is the amount of information in something, okay? So you try to use all your capability to define your own definition of information and listen to the lectures. Or if you are very hasteful, then just Google it, okay? Information, Wikipedia. And then there will be a lot of pages talking about definition of information and what are the issues in information storing and transmission, something like that. Anyway, but I will defer that discussion and give you a chance to think yourself. Okay, here goes one of my best stories. So long ago, in the time of myths and legends, there was a warrior named Stantor. Okay, and as you know, this is not Homer Simpson's Homer. It's you have Iliad and Odyssey, Iliad and Odyssey, written by Homer. And according to Homer, there was a person named Stantor who could speak very, very loud, 50 persons' voice at a single time. And you may wonder, okay, he has a big mouth. What's good for that? And he was drafted by probably Agamemnon and sent to Troy. Why? Think about a battlefield long ago. Okay? So usually the directors or generals are stationed in an uphill and look down the battle place. And what do? Sometimes they use some instruments, but that it may not be enough. For example, they may use whistle. Okay, everybody, if I whistle once, then move right. If I whistle twice, move left. But sometimes you are just simply disoriented in the battlefield. And you may whistle twice, and some of your dumb soldiers may move to the right. So this voice communication is very important. Whatever intelligent quotient a person have, usually they understand our instruction spoken. So this guy, Stantor, could be very, very useful in a battle or a war. Just to say, hey, Stantor, let them move that direction, having that direction to the mountain, something like that. And Stantor says in a very loud voice, move toward the mountain on the blah, blah, right? The problem is that the heroes in Iliad cannot live forever. So what happened? I believe these are Romans, not Greek, but Romans invented some strange tube And this is named as stentophone or stentophonic tube. So he's not stentor, but now with the help of some instrument, the soldier's voice can be beamformed to a specific direction. So the power or energy we spread through the air can be focused so that with lower voice, we can send it for long distance. But this long distance may be just a few 100 meters, 1 kilometer best. And you can see that this beam of our voice, the voice can be directed. As you see that there is a lobe. Okay, so when you want to direct the soldiers when on that direction, then you steer it mechanically and then give the instruction, something like that. Sometimes, as you remember from some Greek old stories, that sunlight could be used for short distance communication. What about long distance communication? Anybody knows this subway station in Seoul? I know this because when I did my military service, I was so-called defense soldier, 방위병. And I was living at that time in Yeouido, next to MBC Broadcasting Corporation. The problem was that I had to commute to a barrack near the Gupabal station. And sometimes I took subway after the work in order to go to some place in Seoul area. And I could see this station. This is Gupabal station, third line. Okay? And here, Pabal means what? This system. Okay? This system of stations and horses and riders. What do? They have some carrier, and inside that they put letters, instructions, something like that. Of course, sometimes they use the pigeon. Gu means pigeon, okay, with a small pitch of letters. So using this system of Pabal, our ancestors could send information for over long distance. So here goes short distance solution for communication and long distance solution for communication. And now, what was the problem of these two solutions? What was the problem? So whenever you are questioned some question like this with very open-ended, try to systematically approach. Okay, Professor Joe just said distance, short and long. And distance is related with space. Then suddenly some of your neurons inside your skull says that, okay, let me think about time. So what if we also think about time? Here, our voice travels very fast, especially at that time, around 300 meters per second. So, okay, sunlight, very fast. What about this? It's too slow, right? Probably 60 kilometers per hour best. And sometimes there are mountain robbers, all the information lost sometimes. So in order to reduce the time, they had to do some trade-off. Okay? So here goes one of the most important words in all engineering. Okay? So we are in the College of Engineering. You may not know that. Pohang University of Science and Technology has two colleges. One is College of Science and the other is College of Engineering. And in College of Engineering, this word is one of the most important words, trade-off. So in order to, for example, reduce the time for long distance communication, we have to sacrifice something. What? Of course, we do not want to sacrifice our long distance. What do? We cannot transmit a lot of information at that time, okay? So here goes a trade-off. Signal fire or signal smoke. And this picture is not this one. This is taken by myself. By the way, a lot of pictures of figures are just pirated from the web, okay? But this is not one. This is my own picture. There are 5 chimneys, okay? And how many messages? Here goes the question. How many messages our ancestors transmit using this 5 chimney 봉수대 system? Anybody? So mathematically, you can turn on, off each of 5 chimneys. So we have up to 2 to the 5, which is 32, different messages that can be transmitted over this network. By the way, this network was not invented our own ancestors, and the history says that it was invented in China. And at that time, any useful Chinese invention was quickly adopted by Koreans and Japanese. So we also adopted this one. And as you've already seen here, our ancestors just conveyed 5 messages using this system. And you may say that, okay, they were very dumb, right? 32 messages can be conveyed, but only 5. But that is not true. They intentionally limited number of messages. Why? Let's think about situation, okay? So some of you are from Busan area and know the 동래 산성 or 금정 산성 located in Busan. And think about 1592, the year 1592. What happened? Imjin War happened. Okay, so a lot of Japanese invaded Busan area, Busanpo area, and so probably Joseon dynasty had the 봉수대 located on 금정상성. What would happen? So here, this is normal time, single smoke or fire. Okay, a lot of Japanese battleships. So 2 smokes. And some Japanese landed. 3 smokes. And not only landed, they start to march. And here, 동래부사 송상현 has just died. Got it? Now, suppose Japanese invaded very quickly, so the soldier under this system was just start to make the 3rd or 4th or just 2nd chimney to make smoke, but some Japanese samurai just slighted him. What would happen? Or Japanese soldiers just pour the water, and for example, these 2 chimneys are off. Now, some of you are located in this 봉수 system, and especially in, okay, which area? Gijang area, for example. You know Gijang-gun or Gijangmyeon. And you see the Kumjang Mountains system, and some strange thing happens, right? The 1st and 4th chimney, and you look up the manual, And there is no such message. But you know that at least this or that situation happened. Right? This is so-called what? Forward error correction, which is one of the most important error control scheme. Okay, so using the system, you can transmit 32 messages up to. However, you do not transmit 32 messages. You transmit less than 32 in order to have what? Error correction capability. This is very important. Actually, in our most of the communication systems, we adopt error control scheme, especially forward error control method. Okay? So our ancestors or Chinese ancestors were not dumb. They were very clever. And also think about this. Let's consider a peaceful time. Now, why this system is called 봉수 system, 봉수대 system? Here, I spelled out here, 봉 means 횃불, fire, 수 means smoke. Okay, so this is a signal fire and smoke system. And at night, suppose it's first day or last day in lunar calendar. Very dark, right? So you are posted in a remote area in Gijangmyeon and look at the Geumjeong mountain. And suppose there is a single fire you can see. However, at very dark midnight, can you distinguish which chimney emitting the signal? If you can transmit 32 messages. And your message may be the leftmost chimney means peaceful, and rightmost means that aliens invaded with millions UFOs. How can you distinguish at midnight without any lunar illumination? Right? So even due to that reason, you cannot transmit 32 messages reliably. Okay? So here goes another word. Reliable communication. So this time is almost up. So let me give you all the information our human beings have accumulated so far. Okay? Ready? Okay, done. I transmitted. How do we do that? So the method is this one. I just put every information in 0101 was something format, and I put this one. And I modify the magnitude of my finger flipping sound and transmit it to you. What happened? No information received. So transmission rate itself is important. However, reliable transmission is also very important, not just fast, right? So in order to make the transmission of information reliable, we introduce error correction scheme. Got it? So ancestors were very, very clever. Now, you may say that, okay, Professor Cho, this sounds very similar to what I have taken in our humanities department, probably history of communication. And then they moved to 신문방송학. Now, let's move to our topic. What will be covered in this course? I'm not going to talk any more about 봉수 system. I will talk about electrical communication system, which means that since I will talk about currents, voltage, antennas, electromagnetic waves, light waves, infrared, acoustic signal, something like that. And I will also talk about electrical systems, receivers, transmitters, amplifiers, and those of things in this course. And these are the topics in this course. And in order to handle electrical systems, you have to be prepared to handle electrical signals too. Then what will be the required course? Signals and systems. So, okay, let me finish today's meeting. And I strongly recommend you to review signals and systems, especially Fourier series and Fourier transform, continuous time Fourier series and Fourier transform, until the end of Chuseok break. Okay, that's all for today.